So in this video, I'm going to work through the solution for problem 7.15 out of Griffiths, Introduction to Quantum Mechanics, Edition 3. And if you'd like these type of solutions or solutions to other problems, please give the video a like and subscribe. I'll do videos on a range of physics topics and math topics, maybe other topics as well, but mostly going to be quantum mechanics this semester. I'm taking my last undergrad quantum class, so I'm kind of focused on that. Next semester will probably be a good amount of mechanics and mathematics, and after that I graduate, so I guess we'll see what happens. I guess I'll have a little bit of time to do what I want, but for right now, I'm going to go through some of these problems. So this is actually problem 7.15. Alright, so let's go ahead and get started. So a little bit of motivation behind this. This is chapter 4. I was just reading back a little bit, but if we go to the chapter in interest over here, the relativistic correction. So essentially what we're doing is we're using our relativistic equations for energy and momentum and trying to find an energy correction. And when we do that, we find this factor of the expectation value of 1 over r, also a 1 over r squared. And in the book, in the text, they just tell you what 1 over r is, but in this problem, we're going to prove it. So, okay, that's the motivation, and I just highlighted it here. So let's go ahead and get started. So first off, our potential, this is for a hydrogen atom, is minus e squared over 4 pi epsilon naught, and then the expectation value of 1 over r. And this is equal to 2 times e sub n. And that's the, so that's our theorem there. So now we can solve for 1 over r, or the expectation value of 1 over r. And just multiplying and dividing over, that's going to be minus 4 pi epsilon naught over e squared, that's our fundamental charge, times 2 times e sub n. Now e sub n is equal to e sub 1 over n squared. And if we plug in what e sub 1 is, so that's going to be minus the mass of electron over 2 h bar squared times the fundamental charge e squared over 4 pi epsilon naught squared times 1 over n squared. So this is equation 4.70. We're going to use that equation. And we can plug that in for our e sub n here. Okay. So minus 4 pi epsilon naught. So right off the bat, this e squared will cancel with one of these e squareds. That's squared, so that's really e to the 4th. So we'll be left with an e squared. So times a minus m sub e. Now this 2 and this 2, that's just 1. 2 over 2 is just 1. Over that h bar squared. Like I said, that's e to the 4th, so now it's just going to be e squared because of the e squared in the denominator. 4 pi epsilon naught squared times 1 over n squared. And, well, these negatives will go positive. 4 pi epsilon naught will cancel with 1 here. And we're left with, I'll do it in red, I guess. We're going to be left with me, so the mass of our electron, e squared over, we'll do the h bar squared first, 4 pi epsilon naught n squared. And there's this term called alpha. which is defined as 4 pi epsilon naught h bar squared over m e squared. So alpha is just this collection of constants, because these are all just constants. And if we take the inverse, 1 over alpha is me e squared over 4 pi epsilon naught h bar squared. And this is just this. That's all this. So then we can say that 1 over r is equal to 1 over alpha, and then we still had this n squared term, which was not included in this alpha term. So that's what we wanted to show. 1 over r, the expectation, is 1 over n squared alpha. Yep. So that's how we do it. Hopefully this helped out, and if it did, like I said, please like and subscribe.